Okay, 2024 question. Then here asking complete the Kana map for the relevant to the above circuit. So circuit we got output uh, for if three inputs are on, output on, or if two inputs are on, output on. Rest of the things are zero. So we got 1 for 3, 5, 6, 7. 1 for 3. We got 1 for 3. They mean 0, 1, 1. And then 1, 1, 0 for 6. That is 6 on, 7 on, 4, 0, then 5 on. Okay. Look at again. 0 position 0, 1, 0, 2 is 1, 0, 0, 3 is 0, 1, 1, then 4 is 1, 0, 0, 5 is 1, 0, 1, that is on, then 6 on, 7 on, 1, 2, 3, 4 on, 1, 2, 3, 4, yes. So this is the out. Can you remember we have done this in another past paper? This also there. 2016 as well as early I can remember there was. It's better to give POS, not SOP. This question is very easy. Yeah? Okay, shall we group it? This is one group. What is the name of this group? When you keep the I here, you will get C this side. Ne? Then on the top, A. So this group will be better to mention which group. A, C. A, C. Then I'll take another color. This group will be, again C is there. B is common. C. Both containing the one B. Then this C. Then again, this one. A, B. We can't take the C. So Z output is equal to AB plus AC. Better to write in an order. Okay. BC. But they won't cut the marks if the question is there or not. But it's nice to write in order. Okay, Z output is equal to AB plus AC plus BC. Check your answers whether you have it. If it is there, give 2 marks. Are they asking using the K-map, derive the more simplified form of product SOP expression for the output Z. Show the loops clearly. What that mean? Clearly. You have to write for which loop you got this output, okay, on the K-map. And another thing, you will get empty K-map for 2 marks without grouping 0, 1, 0, 0. This field K-map without grouping, you will get 2 marks. Therefore, don't write only once. Zeros also should be there because each and every item, each and every output will contain 0.5 or 0.25 marks. හැම සෙල් එකකටම ලකුණක් තියෙනවා. හරි. එකක්වත් ස්කිප් කරන්න එපා. ස්කිප් වුණොත් අපරාධයේ ලකුණ. ගොඩක් ළමයි output එකේ විතරයි ලියන්නේ. output එක විතරක් ලියලා වැඩක් නැහැ. අර බිඳුවට ලකුණු හම්බ වෙනවා. ඒතර ඔතන ලකුණු එකක් විතර හම්බ වෙනවා 0.5 හරි 0.2 හරි ඔය චුටි ගානක් දුන්නොත් ඒ ලකුණු ටික ලොස්ට් වෙන නිසා හොඳට මතක තියාගන්න ගෲප් කරන්න ඉස්සෙල්ලා full K map එක අඳින්න හරියට බින්දුත් හරියට දාන්න AB මාක් කරන්න AB හිතේ තිබිලා වැඩක් නැහැ AB මාක් කරන්න කොලම්ස් වල නම් ටික ලියන්න ට්‍රූත් ටේබල් සම්පූර්ණ ෆිල් කරන අර ඉලක්කම් ටික ඕනේ නැහැ 1 2 3 4 5 6 7 ඒ ටික ඕනේ නැහැ. ඒක අපිට දැනගන්න ලේන්නේ. ඒක නැතුව අර අනිත් ටික K map එකේ සම්පූර්ණ ටික ලියන්න ලකුණු දෙකක් එතෙන්ට තියෙනවා. then the grouping group කරලා arrow එක දාලා ඒ මොකක්ද කියලා ලියන්න. clearly show the grouping clearly කියලා කියන්නේ ඒ group එක කාටද අයිති කියන එක. ඊට පස්සේ ෆයිනල් අවුට්පුට් එක වෙනවා. ෆයිනල් අවුට්පුට් එක ලකුණු භාගයක් විතර හම්බෙයි. ඊටු ඔක්කොම ලකුණු ටික බෙදලා යනවා මේක ඇතුලේ. හරි ඒ නිසා හරියට ඔක්කොම ටික කම්ප්ලීට් වෙලා හදන්න වෙනවා ලකුණු හතරම ගන්න නම්. මේක ලේසියි ආ. Okay, draw a logic circuit for more simplified expression derived above in 3 by only using and not and or gates. Not the no, not the nan, and not or. Not the universal gates. හරි මෙච්චර කාලය හැවෙ මොනවද යුනිවර්සල් දැන් පුරුදුලා ඉන්නේ යුනිවර්සල් ගත්ත ගමම ඩබල් කම්ප්ලිමන්ට් දැම්මා යුනිවර්සල් දැම්මා දැන් මේකේ අනිත් පැත්ත අහන්නේ draw the logic circuit for the more simplified expression derived above 3 by using only ඇයි පාස් පේපර් කට බලන්නේ දැන් ඒ නිසා ඔයාලා මොකද කරන්නේ ඔක කොහොම ඩබල් කම්ප්ලිමන්ට් දාලා උත්තරේ හොයාගෙන යනවා අහන්නේ මොකද්ද and not or gates හරි හැබැයි පුළුවන් තරම් අඩු ගේට් ගානක් ගන්න and not or වලින් විතර okay let's get started. Going to make AB. Then we need the B. Use the AND gate. Output will be AB. Okay, then we need the C, AC. If you are taking current, make it a little bit darker and take the AC. Then BC. Use the OR gate and add OR. When you are taking current, make the position where you take in darker. Okay. Output Z should be there. Even though you did not write the entire expression, never mind. Write Z there. If the Z is not there, you will lose it. If you have the time, write the entire expression. AB plus, it is not must. Expression, entire expression is not must, but the Z must be there. AC plus BC. And another thing we are writing, check whether the correct literals are there. සමහර අය වැරදි අකුරු දාලා තිබ්බම විතර අපිට තේරෙනවා මේ ළමයට වැරදිලා කියලා. ඒකට කරන්න දෙයක් නැහැ. ඉතින් හරියට ලියන්න දැනගන්න බෑ. ඒක ලකුණු කැපෙනවා. sorry C බා නැහැනේ. මොකක් හරි නැති ඉලක්කමක් එතෙන්ට දාලා C බා වගේ දැම්මොත් සම්පූර්ණ එක්ස්ප්‍රෙෂන් එක වැරදි. ඒ වගේ වැරදියට දාලා තිබ්බොත් ඒකට අදාළ ලකුණු ටික නැති වෙනවා. Okay. Are there any questions? Explain the use of a use of the half adder in digital circuit. So why we use half adders? To add single bit binary number, single bit. Okay, so if there is carrier bit going to that, then full adder we have to use. Describe how flip-flop work as memory element in digital circuit. Explain how it differ from the combination gates. Okay, flip-flop we use in the sequential circuit. Let's keep it for a while. Draw the truth table for the full adder. We did the half adder. Okay, I'll do the third one first, then later we'll do the flip-flop. Okay, draw the truth table for the full adder. Now complete the third one. We'll do the second one later because today lesson also a flip-flop. Therefore, complete the third one. Draw the truth table for the full adder. Can you remember what is a half adder? Half adder, carry out and the sum out. So this is the half adder. Okay. So half adder we have XOR and the AND gate. So two half adders joined together we call as full adder. Full adder we have the carry bit. So we can add carry bits there. Okay, so this is the full adder circuit. We have two half adders within it. And we took the output, simplified, and then this also full adder. So finally, full adder circuit, truth table output you have to write. Okay, so we'll complete that. So full adder output will be A XOR B XOR C, then AB plus BC plus AC output should be there. So that truth table you have to draw there. The paper is easy, but it will take more time to complete. That's all the problem. Then complete the part 2. Second one. Truth table of full adder, we can take A XOR B XOR C. Output will be 0, 1, 1, 0, 1, 0, 0, 1. Then AB plus BC plus AC. 3 zeros, 1 0, 3 ones. Okay, if you have good practice with, then you can write it quickly. If not, then it will be a little bit hard for you to memorize it. Okay, so then next question we have the describe how flip-flop work as memory element in digital circuit. Explain how it differ from the combination circuits. If I ask this question, I will ask how the random access memory can store data. Because random access memory consists of flip-flop circuits, therefore flip-flop circuit can store single bits. Flip-flop circuit consists of memory element. Then, so we can store the data. Okay, instead of flip-flop, I will ask why random access memory work as memory storage, because it consists of the memory element and it is the flip-flop. So since it is flip-flop, it consists of memory element. Then how it works today we are going to discuss. We'll move to that one now. Okay, sequential circuit output is depend on the present value of the input signal as well as sequence of the past input. That means sequential circuit is a combination of it is a storage element as well as combination circuit. It consists of storage element and the combination circuit. So sequential circuit use current input variables and previous input variables which are stored and provides the data to correct to the circuit on the next clock cycle. That means sequential circuit consists of two sections, combination circuits, and the memory element. So input signal is there. Then while it making the output, the memory element will keep the previous output. That output will take a gain for the next iteration. Okay. So sequential circuits are used for memory storage. SRAM is made out of flip-flop. So memory storages are made out of flip-flops. So flip-flop consists of the memory element. Latch flip-flop stores single bit of data in memory element. So in our syllabus, we will discuss about the latch flip-flop. That also uh, store the memory element in, that means output of the previous iteration, output of the previous circuit. Okay, that means this input will make the output. The output will store in the memory element. Then it will use for the next input. Okay, so the output of sequential circuits depends not only the combination of the present input but also the previous output. දැන් හදන දැන් input එකක් දුන්නා කියලා හිතන්න ඒ input එක හදන output එක හදද්දි එයාගේ සර්කිට් එකේ එන අවුට්පුට් එකේ අවුට්පුට් එක සේව් කරගන්නවා මෙමරි එකේ. ඒ කරගත්තු මෙමරි එකේ සේව් කරපු එක ආපහු පාවිච්චි කරනවා සර්කිට් එකට. ඒතර දැන් ඊළඟ අවස්ථාව හදන ඉන්පුට් එකයි මේ කලින් එකේ මතකයයි දෙකම එකතු වෙලා තමයි අවුට්පුට් එක හදන්නේ. ආයේ ඒකේ කොපි එකක් තියාගන්න. ඒකේ අවුට්පුට් එක තියාගන්න මෙමරි එකේ. ඒ මෙමරි එකයි අලුත් ඉන්පුට් එකයි එකතු වෙලා තමයි ඊළඟට යන්නේ. ආයේ හදන එකේ අවුට්පුට් එක මතක තියාගන්න. එතකොට ඒ මතකෙයි කලින් එකේ අලුතින් එන ඉන්පුට් එකයි මතකයේ දෙකම එකතු කරලා තමයි අවුට්පුට් එක හදාන්නේ. හරියට අපි මේ මැෂින් එක පාවිච්චි කරනවා වගේ. අලුතින් කරන වැඩේ ප්‍රීවියස් එක අපි අඬු කර පස්සට යන්නේ. අන්න ඒ වගේ කලින් මතකයයි දැන් අලුත් එකයි එකතු කරලා ඊළඟ කරනවා. ඊට පස්සේ ආයේ ඒකේ මතකය ආයේ සේව් කරගෙන ඒකත් එක්ක අලුත් එකක් ගන්න. So it will use the previous memory with the help with the input. Then it will make the new output. Then new output again go to the memory element and use with the new input with the output. Then it will previous output and it will make the next output. Okay. So then there was a past paper question 2021 or 20. Okay. A block diagram of the sequential logic circuit is shown below with block label as A and other label as B. A, B. Okay, what is the A? As we discussed, A is combination circuit. B, memory element. Okay, so A is combination circuit, B is memory element. Actually, A consists of no gates. Two no gates. A consists of two no gates. Now we'll see what is there. Which of the following statement about the block diagram are correct? Asking the correct one. Block A is a combination circuit. Yes. Block B is memory element. Yes. Only the block A can be implemented using the logic circuit. No. Not only. B also made with the logic circuit. That means entire thing. This entire flip-flop is this one. So here only keyword only is wrong. Therefore answer take as 1 and 2. We'll draw this circuit. So this circuit is equal to this one. Instead of this, we can replace. This is the combination of combination circuit and the memory element. මේක ඇතුළේ තියෙනවා memory element එකක්. එයාට මතක තියාගන්න පුළුවන්. මේක combination circuit එකක්. එතකොට අපිට මේ the block A can be implement only කියන keyword එක that means මෙතන මෙයා only the block A නෑ block B එකත් හැදෙන්න මේක උදව් වෙනවා. block B එක හැදලා තින්නේ මේ එයාගේ මතකය ආපහු කරකවලා දීපු නිසා. අපි ඉස්සරහට මේ circuit එක හදනවා. Then difference between combination circuits and the sequential circuits. මම මේ දිගටම කරන් යන්නේ අර ප්‍රශ්නෙට උත්තරේ ඕන නිසා. හරි ඒක අහන්නේ මෙදින අතර වෙනසනේ. බලන්න. Output depends only the present input. Combination circuits කලින් හදපු flip flop half adder full adders වලදී output depends only the present input. Half adder, full adder, output depends only the present input. But sequential circuit, it consists of the memory element and the combination circuit. So output depend on both present input and the present state and use of output of the previous. පරණ මතකෙත් ඕනේ combination මේ sequential circuits පාවිච්චි කරලා මොකද memory element එක තියෙනවා එයා පරණ මතකෙ තියාගෙන අලුත් input එකේට පරණ මතකෙ පාවිච්චි කරලායි ගන්න. එතකොට sequential circuit කියන්නේ flip flop වගේ අය combination circuit කියන්නේ full adder half adder memory element පාවිච්චි වෙන්නේ නැහැ මේ combination circuits වල full adder half adder වලට memory element තිබ්බේ නැහැනේ අපි කලින් කතා කරපු. හැබැයි sequential circuits වලට memory element එකක් ඕනේ පරණ මතකය අපව ගන්න. එතකොට easy to design the combination circuit. මෙයා difficult to design. Clock signal is required in flip flop. Flip flop එකට clock signal එකක් කියලා එකක් පාවිච්චි වෙනවා. එතකොට ඒ දෙක අතර වෙනස්කම් ටික තමයි මේ ටික. So combination circuit output depends only the present input. Sequential circuit output depends on both present input and the previous present inputs and present state use the previous output. කලින් මතක පාවිච්චි වෙනවා. Combination circuit do not use the memory element, but the sequential circuits use the memory element. Then we'll move to the question. Okay, so describe how flip-flop works as a memory element in digital circuit. Explain how it differ from the combination circuits. So flip-flop consists of the memory element and the combination circuit. Okay, so for that answer, flip-flop is consists of the memory element and the combination circuit and output depend on the present value of input and as well as sequence of the past input. It needs the past input. Okay. This is for the past paper question answer. Then ask the differences. Differences mean this one. Okay. So it's better to use only first two. No need all. First two answers should be there. Okay, let's start it writing. So flip-flop logic circuits mean random access memory, that means basic circuit of the random access memory. This is the answer for the 2024 question paper, and then you have to copy it later. We'll start the lesson. Sequential circuit. Copy down the non-sequential circuit, this one, and then this one, and this. Up to this one, complete it.